I do love easier times. And there were easier times back when I was in elementary school. You probably were in elementary school too. When you learned how to do math without using a calculator. Okay? So what I would like you to do now is I would like you, without the use of a calculator, so all paper and pencil. Math is done in pencil, right? Okay? I want you to divide that out. 91,789 divided by 84 without the use of a calculator. Love it. Just quoting all the movies today. Talk to me, Goose. What do we do? Big division symbol? Small one or a big one? Well, like... Big one. Yep, we like. Division problems need to breathe, especially when you're doing them by hand. Okay, love it. Then what? On the outside left side. Whoop, that's... Pick somebody. But it can't. Yep, exactly. Okay, so that'd be a 0. So do I have to write a leading 0? No. No, don't have to write a leading 0. Okay, so then what? So see how many times that 84 goes into 91? Okay, so how many times does 84 go into 91? 1 time. So I put the 1 that it goes in there above the 1, right? Okay, then what? Okay, and you said I subtract, and that gives me 7. Okay, pick somebody. Now I bring down the 7, yep. I drop it like it's hot. Okay, then what? So what do I put above the 7? A 0. Okay, pick somebody. All I heard was mumbling. Lady. Bring down the 8. Then what? Other way around. 84 goes into 778. How many times? 9 times, did you say? Yep. And what is 9 times 84? 756, did you say? Then what do you do? What do you get? Good job. Thanks, Kaylee. Pick somebody. Go ahead and bring down the 9. Twice? 168? 61, you said? What if I didn't want to add a decimal? What? Because I want to be exact.
You didn't add it? I'll just add a 0 to it.
We put a remainder, right? So my answer here would be 1,092 with a remainder of 61. Right? Is there another way that I could write that? That exact same thing. In maybe a different form.
Is it like 61 over 84?
Where would that go? So give me the whole thing.
The 1,092, and then next to it is 61 over 84.
And 61 84ths. What if 61 over 84 was reducible? It's not, but what if it was?
Then you reduce it.
Then you reduce it, because we like reduced fractions, right?
Yep.
Love it. Those are the two exact answers. Okay? Rat, were you the one that said throw an extra decimal point and a 0 and all that stuff? Okay? That would be if we were rounding. Okay? Yeah, but we're exact. We're cool like that. We like to be exact. Yeah. Any questions on this? All coming back to you? Fourth? Third? Somewhere in that range? Third, fourth grade? Okay? Alright? Today, I promise you when I say that, when I say this. Not when I say that, because third, fourth grade doesn't mean anything. Okay? Alright? I promise you when I say this. That's as hard as it gets today. Okay? Probably even harder. Because they wouldn't let you use a calculator. And you had to multiply 84 by 9. You know, cotton-headed nitty bundle. Okay? Alright? Okay? That's as hard as it gets. Okay? But today, that's what we're going to be doing. We are going to be dividing polynomials today. Okay? And so we're going to use long division today. Okay? And we're going to want to do that because we want to get to the point where we can divide out polynomials, factor polynomials, and solve polynomial equations. And that's what we want to get to today. Alright? So, in order to do that, we're going to use long division. Okay? So, I'm a step kind of a person. Again, OCD is a real thing. First thing you got to do is you got to set it up. Okay? So if it's after the division symbol or the denominator, that's what's going to go on the outside of the big fraction, the old school fraction symbol. Or not the old school fraction symbol, excuse me, the old school long division symbol. Okay? So in this case, it would be x plus 3. If it's before or the numerator, that's going to go inside. Now, one thing that we've got to do is you got to make sure that all exponents are there. Okay? So what I mean by that is, William, I thought you only left 20 minutes to go in class. Oh, no.
Yeah,
It's 30. Yeah. I'm sorry. My fault. I just wrote it down today. I thought I wrote 20. So, my fault. Okay. So, what I mean by that is we've got a degreed term, right? Term with the biggest exponents is the degree. So the degree of this polynomial is 3. So I need to have an exponent of 3, of 2, of 1, and of 0 in there. Okay? So I've got my exponent of 3, I got my exponent of 2, I got my exponent of 1, I got my exponent of 0. Okay? Alright, so I got them all there, so I can write it as is. 3x cubed plus 17x squared plus 21x minus 11. Love it. Okay? Exciting. Okay? So now we've got it set up. Step number 2 now is going to be the Nike step. Okay. We going to divide. Okay. So what I'm doing is I'm going to make my first look alike. So I want, this is my first term out here, I want it to look like that first term inside. So using multiplication, how do I make x become 3x cubed? Multiply it by 3x squared. Now I'm going to write that 3x squared in my x squared column. Couple of key points for organizational skills. 1, these problems need to have room to breathe. Okay? You cannot cram these problems into a corner. They will fight back. Okay? All right? Second, you want to line everything up vertically. So since we said we're going to multiply by 3x squared, I'm going to put that in the above the x squared term. Okay? Right? That way, all of my x squareds are in a line. And you will see when we're done with this problem that all of my x squared terms are in a line. All of my x terms are in a line. All of my number terms will be in a line. Okay? Jazz, you had a question? Okay. All right. So now what I'm going to do is I'm going to say 3x squared times x plus 3. Okay, so I'm going to multiply those together just like we did on the numbered problem. Okay, first we did 1 times 84, then we did 0 times 84, then we did 9 times 84, and then we did 2 times 84. And that's going to give me 3x cubed plus 9x squared. In the numbers, what did we do then? We subtracted. Okay? So here, what we're going to do is we are going to change all the signs and add. Okay? The kicker is we have to change the signs first. That way then we can now add those two together. When I add them together, the 3x cubes cancel each other out. That's what I want. I want that first term to go away. My next one then becomes 8x squared. Okay. Then we dropped down that next number, right? Well, now I'm going to drop the next term. Okay. And I'm going to do that whole process until I'm done. I just got shocked. Okay. So I dropped that one. Now I want to make x look like 8x squared. What times x gets me 8x squared? 8x. So I take 8x and I multiply it by x plus 3, and that's going to be 8x squared plus 24x. And I change the signs and I add them together. The 8x squareds go away. 21x plus negative 24x is negative 3x. Then I drop the negative 11. Now I start over again. I need to get x to look like negative 3x. What do I multiply by? Negative 3. If I multiply by negative 3, I get negative 3x minus 9. Then I change the signs and I add. And I'm left with negative 2. Now I don't have any more terms to drop down. Okay? So that brings me now to step 4. Step 4 is I'm going to rewrite my answer with any remainder that might happen. Sometimes we get numbers that can go into one another. Like, for instance, 24 divided by 6 is 4. Remainder is 0. But 24 divided by 5 is 4 with a remainder of 4. So we have to incorporate that into our answer. So our answer here would be 3x squared plus 8x minus 3 plus negative 2 over x plus 3. Yes, ma'am. Yes. There is no other option to write it. Okay? Let's try another one. Step number 1. We need to set it up. Outside, what's going on the outside? X plus 3. What's going on the inside? As it's written? Yay or nay? I need to have an x squared term in there, don't I? Okay. So it's x cubed plus 0x squared minus 4x plus 6. Because step number 2 said we got to have, if we have a degree of 3, we got to have an exponent of 3, an exponent of 2, an exponent of 1, and an exponent of 0. Okay? X needs to become x cubed. What do I multiply by? X squared. Then, what do I do? Bring down the negative 4x. X now needs to look like negative 3x squared. Excuse me, negative 3x squared. What do I multiply by? Negative 3x. Change the signs. Leaves me with 5x. Somebody other than CJ, what do I do next? What? Drop the 6. Need x to look like 5x. What do I multiply by? 5. So I get x squared minus 3x plus 5 plus negative 9 over x plus 3 as an answer. What do you mean? Like these? Nope. Nope. Because if it did, then we did something, or if it is reducible, we did something wrong in the problem. Okay? Setup, same. It's all about the first, right? How do I make x squared become x cubed? X. Change the signs. Drop down the negative 7. X to 4x squared. Excuse me, x squared to 4x squared. Plus 4. Yes? So my answer here is x plus 4 plus the fraction 6x plus 1 over x squared minus x minus 2. Try that one. I get 2x cubed minus 6x squared plus 5x minus 15. Yes? What does that mean? More importantly, what does that mean? Other than the fact that we don't have a remainder. What? What does it mean to be divide? What do you mean by divide equally? So like what does that mean? Use math terms.
Can you give me some examples of math terms I can use?
Yeah. You've used a bunch already. But you haven't used the right one yet. Everything you're saying is true.
Reducible by that, basically.
No, not reducible.
I don't know what you're doing.
they're not equal. No, they're not equal, that's for sure. Having a remainder of 0, what does that mean about x minus 3, or excuse me, x plus 3 and the original equation?
Oh, isn't that a solution of it?
No,
No, it's not.
not a solution.
When x equals -3, right?
X equals -3 would be a solution, yes. But what is x plus 3? It's a factor. Had you been paying attention earlier when we did the 24 divided by 4, and we said that 4 was a factor because it had no remainder. Okay, I know. Okay, but so that means that x plus 3 is a factor. What was the original one? 2x to the 4th minus 13x squared minus 45. And it means that x equals -3 is a solution, a root, a 0, or an answer. To the function. Yeah. So with that being said, is that a true statement? Is that a true statement? Yes? Okay, that's a true statement. Is this a true statement? Yes? No? Maybe? Is this a true statement? Is that a true statement? Because what are the other two? The other two are imaginary, because 2x squared would have to equal -5. Okay? So, long division, don't even think about packing up yet. long division, yes, it is just that. It is long. But it leads us to, 1, completely factoring a polynomial, and 2, it leads us to solving a polynomial. Okay? Okay? Your homework this evening is going to be a worksheet. It will be due on Wednesday. You still have a formative tomorrow. However, I did change the day of your test. Your test was originally scheduled for Thursday the 14th. I moved it back to Friday the 15th because I totally forgot that we don't have